Welcome to A-Level and AP Physics. In today's lesson, we will discuss past paper questions from March 2024, Paper 4, Variant 2. As always we will discuss these questions in detail so you can improve your conceptual understanding of physics and also you can have better understanding of these exam questions. Let's study together, let's improve together. Question 7 part A says, a photon has an energy of 3.11 times 10 to minus 19 joules. Calculate the momentum of the photon. So energy is given to us. Now we need to relate this energy with momentum. So how we can relate? So first of all, we need to understand energy of a photon. This is equal to hc over lambda. This is energy of single photon. And momentum is equal to h over lambda. So you can see from here, h over lambda, this is momentum. So we can say from here, E is equal to P times C. We need to calculate momentum, so simply momentum in this case will be equal to E divided by C. C is a constant. Value of E we have, this is in joules. So you need to look at this one. This energy should be given to you in joules. If this is given in electron volts, as most of the time you will see in the question, energy will be given in terms of electron volts, mean in units of electron volts. So you have to convert that into joules. In this case, already energy is in joules, so simply we can write down 3.11 times 10 to minus 19 joules, and C is a constant, that is equal to 3.0 times 10 to 8 meters per second. Now if we simplify this one, in this case we will get value of momentum that will be equal to 1.04 times 10 to minus 27. So you will write on here 1.4 times 10 to minus 27 newtons second. So this is our final answer. Pretty straightforward one, but these two equations are very important for quantum physics. Part B says a laser beam has a power of 350 milliwatts. The light from the laser has a wavelength of 640 nanometers. Determine the number of photons emitted by the laser in a time of 1 second. In order to answer this question, simply you can start with power. Power is equal to energy over time. So we can say this is energy over time, but this is not very clear. Energy is not the energy of single photon. Here we are talking about total energy of laser, total energy emitted by the laser in given time. So we can say given time, and total energy will be equal to the number of photons times energy of single photon. Like this you need to understand physics, divided by time. So in this case we can say time is t. So value of P is given, so simply we can write on here first of all P, this is equal to E. I will be writing P here, means energy of single photon divided by time. So we need to find out N. So N in this case simply will be equal to PT divided by energy of single photon. So we can say energy of single photon. So what is value of P? Value of P is 350 milliwatts, 10 to minus 3 watts, and the value of time is 1 second, and energy of single photon, as we discussed before, E is equal to hc over lambda. So simply we can write on here hc over lambda. So I'll be writing here value of Planck's constant, that is 6.63 times 10 to minus 34. C is a constant, that is 3.0 times 10 to 8 divided by lambda of photon, that is 640 nanometers, means 10 to minus 9. So this is energy of photon. And this value simply we need to plug in here now. So you can copy these values here, 6.64 times 10 to minus 34 multiplied by 3.0 times 10 to 8, and this is divided by 640 times 10 to minus 9. So you can calculate this value here and then you can solve. You will find value of N will be equal to 1.1 times 10 to 18, means 10 to 18 photons we need for this much energy, means 350 millijoules of energy. So this is the answer. This is how you can approach. This question is also very common in past papers, so you need to understand how to approach this one, because most of the time when students they look at this question, they get confused, they don't know how to approach. So you need to understand what is this energy, what energy is this one, and what is this. So you have to be very clear about this one. If these are clear to you, next time you can handle this type of questions with confidence. Second part says the laser beam is incident normally on a surface that absorbs all of the photons. Show that the force F exerted on the surface by the laser beam is given by F is equal to P over C, where P is the power of the laser beam, is not the momentum, and C is the speed of light. So we can sketch first of all. So imagine this one is the surface, and we can imagine photon like a ball. So this is the photon, it's moving downwards. It has certain momentum just before the surface, so we can say that momentum is P, and now we can take downward as positive. So we can take actually up is positive direction of force, so we can say upward force, this is upward direction is positive. So what is the change in momentum? Photon is absorbed, so the final momentum we can say P final, this one will be equal to 0. So what is the change in momentum? Delta P, that will be equal to 0 minus initial momentum, that is minus P. So it means this is equal to plus P. So this is the change in momentum. So how we can find the force on the photon by the surface? This resultant force or the average force, this will be equal to delta P over T, means the time at which force is acting on the photon, delta P over T. So how we calculate momentum of the photon? We have just discussed that momentum of the photon is E divided by C. We have done this one in part A. And how about time? Time, we cannot leave T here like this because T is not in the final answer, so we have to replace T with something. So we have energy, so if I say T is equal to E over P, P is the power, so we have to bring power back. How do I know I have to use this equation for time? Because in the final answer I need power of the laser beam. So we have also discussed this point before. So T is equal to E over P because power is equal to energy over time. Now simply we can plug in these two equations here. So we have this is E over C, and this is divided by E over P. So we can simplify, we can say this is E over C, and here we have this is P divided by E. So this E will be cancelled with this E, so simply we will get F is equal to P divided by C. So this is how we can calculate force. So this is the way how you need to answer. When you answer questions in physics, try to understand, try to develop your understanding, because physics is a way of thinking how to answer problems. Part C says light of a single wavelength is incident on the surface of different metals. The work function energy of the metals is given in table 7.1. Explain the term threshold wavelength. Threshold wavelength means maximum value of the wavelength that can cause emission of free electrons from the surface of the metal. Mean electron is emitted from the surface of the metal with zero kinetic energy. That value of wavelength is threshold wavelength. Now let me show you how you can write down your answer. This is how you can write down your answer. In the answer you have to say maximum wavelength of electromagnetic radiation, not maximum wavelength of photon. Maximum wavelength of electromagnetic radiation that causes electrons to be emitted from surface of metal. So this is also important, from surface of metal. You can also say with zero kinetic energy. So if you want to write down in a proper way, if it has 2 marks, you can say with zero kinetic energy. So this is how you need to answer. Second part says for the metals in table 7.1, calculate the value of the largest threshold wavelength. So in order to answer this question, we need to understand that E is equal to hc over lambda. If this value is the highest, this value means the work function, this has to be the minimum. So this value, because this is E minimum, minimum energy of the photon, that is equal to work function. So we have to take the smallest value of work function. So this value we have to take. Then simply we can use the formula that E is equal to hc over lambda. We need to understand the unit of work function is electron volts, and 1 electron volt, this is equal to 1.60 times 10 to minus 19 joules. This value is given in the data. You can remember this one, or you can find this value in given data. So now simply we can plug in values. E is 2.26 times 1.60 times 10 to minus 19, and value of H, this is Planck's constant, 6.63 times 10 to minus 34, and C is constant, 3.0 times 10 to 8, and value of lambda we need to find out, so we can say this is lambda naught. Now if we solve this one, you will get value of lambda naught means threshold wavelength. This will be equal to 5.50 times 10 to minus 7 meters. So this is the final answer. This is how you need to approach questions from quantum physics. This question is very nice question to practice about quantum physics. If this question makes sense to you, it means most typical questions from past papers you can answer. I hope this video makes sense and this video was helpful and you have better understanding of these exam questions. If these videos are helping, please like and subscribe, and also join Patreon if you are looking for extra resources. And if you have any questions, you can leave in comments and I will try to answer as soon as possible. See you in next video.